Hello everyone. Today we are discuss the Stokes law and we are also calculate the expression for the Stokes law, and it can be proved by using the dimensional analysis. When a body falls through a viscous fluid, it drags along with it the layers of the fluid in contact with it. What the layers of the fluid at a large distance from the falling body remains undisturbed. The falling body produces relative motion between the different layers of fluid. Due to this, the relative motion, a backward dragging force comes into play which opposes the motion of the falling body. This opposing force or dragging force increases with increase in the velocity of body. It is found that the body, after attaining certain velocity, start moving with the constant velocity in the fluid. This uniform velocity of body when moving in fluid is called terminal velocity, where the Stokes prove that the viscous drag acting on a spherical body of radius r moving with the terminal velocity v in a fluid of coefficient of viscosity eta is given by capital F equals to 6 pi eta rv. We can be proved this equation F equals to 6 pi eta rv. This is called Stokes law. Stokes law can be proved by using the method of dimensional analysis. We know the dimensions of coefficient of viscosity, radius, terminal velocity. Then we will be calculating the Stokes law by using the dimensional analysis. The viscous drag or force acting on the sphere that can be depend upon the radius of the sphere, terminal velocity, and coefficient of viscosity of the fluid eta. Therefore F is equals to k r raised to power a, v raised to power v, eta raised to power c. Here k is dimensionless constant. Capital K will be represents the dimensionless constant. Now we can be using the dimensional formula of various quantity which are involving in equation number 1. We get the dimension formula of the force is ml t minus 2, radius is capital L, velocity is L t minus 1, and coefficient of viscosity eta ml minus 1 t raised to power minus 1. Now we can be compare the dimensions. Therefore from the right hand side, therefore m raised to power c, L raised to power a plus b minus c, t raised to power minus b minus c. Now we can be compare the powers of capital M, L and T on the both side by using the principle of homogeneity. Then we get, now we can be comparing the coefficients. Now we can be comparing the powers of M, L and T on both sides we get. Therefore C equals to 1, this equation number 2. A plus B minus C equals to 1, that will be equation number 3. minus b minus c equals to minus 2. This is the equation number 4. Now we can be using the equation 2 in equation 4. We get, after solving this, we get v equals to 1. The value of v is equals to 1 and c equals to 1. Now we will be calculating the value of a. Therefore, from equation 3, we can be substituting the value of c and v will be here. Now we will be calculating the value of small a. Therefore, small a is equals to 1 minus v plus c, that can be equals to 1 by substituting the value of c and v. Therefore, equation 1 becomes, we can be substitutes the value of a, v and c in equation number 1. We get, therefore, f equals to k r v eta. Here a ki power, that can be equals to a equals to 1, v equals to 1 and c equals to 1. Therefore, capital F equals to k r v eta. The value of k, that can be found numerically equals to 6 pi. Therefore, f equals to 6 pi eta r v. This is Stokes law. Now we are calculating the expression for terminal velocity. What is the expression for the terminal velocity? For calculating the expression for the terminal velocity, when a body is dropped in a viscous fluid, it is first accelerated and then its acceleration becomes 0. It attains a constant velocity called terminal velocity. ठीक है, तो terminal velocity, how to calculate the terminal velocity? When a body is dropped in the viscous fluid, it is first accelerated and then its acceleration becomes 0 and it can be attained the constant velocity, and this velocity is called terminal velocity. For calculating the terminal velocity expression, let us consider the spherical body of radius r falling through a viscous fluid having density sigma, and coefficient of viscosity, that can be represented by eta, and rho will be the density of the material of the body. The various forces acting on the body falling through the fluid are, first will be the weight in downward direction, second will be the upward thrust, capital T, equals to the weight of the displaced body, and third, the viscous force in the direction opposite to the direction of motion of the body. Therefore, net downward force acting on the body, that can be equals to weight minus tension minus force. When the body attains terminal velocity, that is the terminal velocity, that will be the constant velocity. Terminal velocity, that can be the net force acting on the upon body is r 0 square, that is w minus t, rho minus f, sigma multiplied by 0. G divided by therefore force equals which to is the expression w minus for t. This terminal velocity. Now we can apply the Stokes law. F equals to 6 pi eta rv, where v is the terminal velocity. Therefore, weight of the body, that can be equals to w is equals to mg, that can be equals to volume multiplied by density of body multiplied by acceleration due to gravity. Volume of sphere, that can be equals to 4 upon 3 pi r cube rho g. This equation number 3. Now, upward thrust, capital T, equals to the weight of the fluid displaced, that is again equals to volume multiplied by density of the body, density of the fluid multiplied by acceleration due to gravity, that can be equals to 4 upon 3 pi r cube sigma g. This equation number 4. Substituting the value of equation 2, 3, 4 in equation number 1, we get 6 pi eta rv is equals to 4 upon 3 pi r cube rho g minus 4 upon 3 pi r cube rho sigma g equals to 4 upon 3 pi r cube rho minus sigma multiplied by g, that can be equals to v equals to 2 upon 9 r square sigma minus rho multiplied by g divided by eta.